So now in this matrix we can replace the value of h of beta I and x of beta I with the values that we have calculated. So in the left hand side we have S0, S1, S2, S3, and the matrix as it is 2 0 0 0 minus 1 2 minus 2 minus 1 minus 2 1 3 0 and 1 minus 1 minus 1 1, and we have h0 by 2 0 0 0 0 h0 plus h1 by 2 0 0 0 0 h0 minus h1 by 2 0 and 0 0 0 h0 plus 2 h1 by 6, and substituting the value of x of beta I, so we have x0 plus x1 plus x2 x0 minus x1 plus x2 and x0 plus 2x1 plus 4x2. Okay, so now we will further decompose this matrix. So on one side we will separate the signals, that is x0, x1 and x2, and the pre-computation matrix will be a 4 cross 3 matrix because it is a 3 cross 1 matrix. So its elements are 1 0 0 because first row is only x0, second is 1 1 and 1 x0 plus x1 plus x2. So next is 1 minus 1 plus 1, and the last row is 1 2 and 4, and this is a diagonal matrix that will remain as it is. It's 0 by 2 0 0 0 0 h0 plus h1 by 2 0 0 0 0 h0 minus h1 by 2 0 0 0 0 h0 plus 2 h1 by 6. Okay, and we have 6 at this point. And this matrix as it is 2 0 0 0 minus 1 2 minus 2 minus 1 minus 2 1 3 0 and 1 minus 1 minus 1 1. Okay, so this is a pre-computation matrix that will combine the incoming signals. This will be pre-computed. These are constants coefficients, so this can be pre-computed, and this is a post addition matrix that will add these calculated terms. So computation carried out are first I can write capital H0 is equal to small h0 by 2, capital H1 is equal to h0 plus h1 by 2, capital H2 is equal to h0 minus h1 by 6, and capital H3 is equal to h0 plus 2h1 by 6. So these are pre-computed. So these are pre-computed. In second step, the pre-computation matrix, with the help of pre-computation matrix, the signal will be added or subtracted accordingly. So capital X0 is small x0, this is capital X0, capital X1, capital X2 and capital X3. Capital X1 is X0 plus X2 plus X1, and capital X2 is X0 plus X2 minus X1, and capital X3 is X0 plus 2X1 plus 4X2. Then S of beta I is equal to H of beta I into X of beta I will be performed. So S of 0 is capital H0 into capital X0. S1 will be capital H1 into X1. S2 will be capital H2 into X2, and S3 will be capital H3 into S3. And then finally post addition of this computed term. So small s0 is 2 times s0, small s1 is minus s0 plus s3 plus 2 times s1 minus s2, small s2 is minus 2 s0 plus s1 plus 3s2, and s3 is s0 plus s3, capital S0 plus capital S3 minus capital S1 plus capital S2. So this can be easily derived from this expression. So now if we see the total number of multiplications and additions required to implement this, so total number of multiplications are this multiplication 1, m1, m2, m3 and m4. So total 4 multiplications are required. And talking about addition, so this is addition a1, a2, this is same as a1, so we will not count it twice. This is a3, a4, a5, a6, a7, a8, a9, a10. This is same as a6. So this is a11 and a12. So total 12 additions. Okay. So in direct form, the total number of multiplications were 6 and additions were 2. And using Cook Toom algorithm, the total number of multiplication is reduced to 4, that is reduced by 2, and addition is increased drastically, that is 12. So based on the last example, I can make following comments based on the observation. So the comment number 1 is that number of multiplications are reduced, but at the same time number of addition operations is increased. Okay, evaluation of h of beta I and x of beta y will involve some addition and multiplication by small constants. Okay, like this is a addition operation, multiplication by 2 and 4, and addition and subtraction operation. So this can be ignored as far as beta I is small. Some addition operations can be shared, like a1 are same, a6 and a6 are same, so they need not to be computed twice, only one time we have to compute this. Next is that the previous example that we have considered, okay, we can consider it as a passing 3 data samples, that is S0, X0, X1, X2, passing through a 2-tap filter with coefficient H0 and H1. Okay, so the term capital H0, capital H1, H2 and capital H3 can be pre-computed as they are constant coefficient. So these terms H0, H1, H2, H3, capital H0, H1, H2, H3 can be pre-computed. And the Cook Toom algorithm decomposes the convolution in the following form. So S is equal to the matrix S is equal to matrix C into matrix H into matrix D into matrix S. So C is post addition matrix, H is a diagonal matrix, D is a pre addition matrix, and this X is signal matrix. Okay.